Okay, good morning, guys. So we've spent a lot of time talking about two-step equations. We've spent some time talking about equations with like terms. So we're going to start talking about equations that involve using the distributive property. So as a little refresher, I think maybe we'll just look at number one here. So for number one, here's my equal sign. That's my dividing line. So I don't have anything on the right other than 44. So I'm going to shoot for my like terms on the left, which are negative 8r and negative r, which I know to be negative 1r. That should combine to give me negative 9r. I also have positive 3 and negative 13, which sum to negative 10. And I bring down my equals 44. So it's a nice simple two-step equation. Negative 9r minus 10 is equal to 44. I will add 10 on both sides so I can isolate the variable negative 9r. It gives me negative 9r equals 54. I'll bring that up here. If negative 9r equals 54, I can divide both sides by negative 9. And I get r is equal to negative 6. So let's take a look at some equations that involve the distributive property. So technically there's a couple different ways we can do this. So I'm going to show you kind of a secondary method that we can use here. The reason we don't teach all of them that way is because it doesn't necessarily always work, and I will explain when we get there. So if we see an equation that has the distributive property and a variable inside, we're most likely going to have to distribute. So this is 7 groups of x plus 8 equals 35. So I probably am going to do is distribute the 7 to both terms. So 7 times x is 7x, whereas 7 times 8 is 56, so positive 56 equals 35. Now we go back to those 3 days we spent on two-step equations. Add negative 56 on both sides. So now I'm looking at 7x is equal to negative 21. I'll rewrite that as a one-step equation. I'll divide both sides by 7, and it gives me x is equal to negative 3. Okay? That's the way that almost all of us are going to do it. Now, I'm sure there's somebody out there that's going to say, well, can't we divide both sides by the 7? And I'm going to say, absolutely. So this is not our preferred method. This is another method that we could use. So if I've got 7 groups of x plus 8 divided by 7, 7 divided by 7 is really 1. So this is 1 group of x plus 8. And 35 divided by 7 is 5. So now it's a one-step equation. So I get x is equal to negative 3. So we say, wow, that was a little faster. That was a little easier. Why don't we always do that? Because if there's other terms on the same side, it's not going to work so well. And that's not to say you can't still do it, but it's really not going to be very efficient. And I'll explain when we see something like that. All right, so let's look at something like this. The only real difference here is that, well, there's two differences. One, there's a fraction outside that needs to be distributed, and two, the coefficient inside the variable is not 1, right? It's negative 8. I'm going to treat this in the exact same way. I'm going to distribute my 3/4. So 3/4 of negative 8 is negative 6, so this is negative 6x. 3/4 of 20 is 15. And again, now we've got this nice two-step equation that we spent so much time on. So now I'm looking at negative 6x is equal to 18. I'm going to rewrite that one-step equation. I will divide by negative 6, and I get x is equal to negative 3. Let's talk about a check. So we've said all along that our check has 3 steps, right? We rewrite our original. We substitute and we evaluate, but as we get more and more into multi-step equations, the checks are going to get a lot more increasingly sophisticated. So I think x is equal to negative 3, so I've got to be really careful with this. So I'm going to bring everything else down exactly as is. And I'm going to really have to be careful with my order of operations. So there's my 3/4. Now, order of operations does not dictate that I distribute. If I'm following order of operations, I need to evaluate what's in the parentheses. And since I have multiplication and addition in the parentheses, I need to do the multiplication first. Now I need to finish off what's in my parentheses. Now finally I have to multiply what's outside by what's inside. So again, the main takeaway is, one, you got to be really careful when you distribute, when you substitute. If I don't have that negative 3 in parentheses, we're all going to do negative 8 minus 3. So that's takeaway 1. Takeaway 2 is when you check, you don't distribute. You evaluate everything in the parentheses, and at the very end, right, over here is where we actually did that multiplication to get 33 equals 33. All right, so here's an example where we're definitely not going to want to divide by what's outside. Could I divide everything by -2? Well, you could, but you'd have to divide the -2 times x minus 5 by -2 and the -30 and the -3x, and that's the one everybody forgets about. So that's why we're going to make sure we distribute. And specifically, guys, again, all these things that I talk about so much in the videos and in person, it's because they come back. All right, I wouldn't go crazy about something if we saw it once and then if we forgot about it, maybe it's not a huge deal. We're going to see this a lot. We need to make sure we're distributing -2 and not 2. So when I distribute -2 to x, I get -2x. When I distribute -2 to -5, I get +10. Everything else comes down exactly as is. Well, now I have like terms. So now this is kind of combining two things that we've done. It's combining our lesson on distributive property today with our lesson on like terms from a few days ago. So now -3x and -2x adds up to -5x. Everything else comes down. Lucky for us, we have a nice simple two-step equation, which we're very good at. I want to isolate the variable, so I add -10 on both sides. That's going to give me -5x is equal to -40. I will rewrite. I'm going to divide both sides by -5. And that's going to give me x is equal to +8. All right, so here's another one, right? Something I spent so much time talking about when we did distributive property, even to some extent with order of operations. What am I distributing? Not the 4, okay? That's the most common mistake I see is we decide we want to distribute the 4. Okay, we are distributing the negative. If you want to call it -1, you can. I typically don't, but you can do that. So if I distribute -1 to -2x, it gives me +2x. If I distribute -1 to +10, it gives me -10. Everything else comes down exactly as is. We do not bring down the negative. We are done with that negative. It is done, it's gone, it's distributed. We do not bring down the negative. We bring down 4. Right? We did -1 times -2x already. So now I've got 4 plus 2x minus 10 is equal to -16. So let's grab our like terms, which in this case are constants. So 4 plus -10 is -6. I bring down my 2x, I bring down my -6. Now, alternatively, if you do not like combining like terms, instead of doing what I just did, you could have added 10 on both sides and then added -4 on both sides. Okay? It's about the same amount of steps. I typically don't do it that way because with variable terms in a few days, it's not going to work so well, but you can do that as well. Let's solve our two-step equation now. That gives me 2x equals -10. And if 2x equals -10, when I divide by 2, we get x is equal to -5. All right, guys, make sure that you are taking notes. Make sure that if you miss something, that you pause it, that you go back. I tend to go a little faster on my videos, okay? And I just caught myself about 3 minutes ago. I was going to say, who has any questions? And realizing I'm talking to myself. But, you know, I can go through it a little bit faster on a video because you have the ability to pause it. So you really just need to hear what I'm saying and you need to see it. You need to be able to pause it to, like, synthesize and make sure it all makes sense. Okay, so make sure we're taking those notes. And you're going to be doing this on your own. That's not to say you just let the video play and you watch what I do and you copy it. This is really, and now try. If you're in class, you're going to be doing it. If you're not in class, you should be doing it. So I would pause it. Okay, and then we come back and I will distribute. And -5 times -10, of course, is +50. I add -50 on both sides. That gives me -5x is equal to -65. Where I divide both sides by -5, and it gives me x is equal to 13. I'm going to put up a check for that, okay? I'm going to take it down, shortly, but of course you can always go back and check it out again in the video. But I'm going to put up a check for that, so I'm going to rewrite my original. I'm going to substitute here in parentheses. And again, I'm not going to distribute. Order of operations does not tell me to distribute. It tells me to do what's in the parentheses, or evaluate, I should say, what's in the parentheses. And we know that this works, meaning our solution for x was correct, that it was in fact positive 13. All right, so like I said, I'm going to take that down for now. If you need to see it, of course, you pause it, you go back to it. So now I'm going to distribute my negative 5. So negative 5 times 4x is negative 20x. Negative 5 times negative 3 is positive 15. Everything else remains as is. Okay? And but that means is, guys, everything else comes down exactly as it was up top. So I'm going to combine my like terms. So on the right side, I've got these like terms, positive 15 and negative 6. When I combine those, it's going to give me positive 9. So my next line should be negative 71 comes down, negative 20x comes down, and then I've got positive 9. I've got a two-step equation where I want to isolate negative 20x, so I need to eliminate my positive 9, so I add its opposite on both sides. So positive 9 plus negative 9 is 0, 71 plus negative 9 is negative 80, equals negative 20x. Divide both sides by negative 20, and we get x is equal to 4. And if I want to go back and just kind of spot check it, which obviously you guys, when we do our work, we're doing a physical check, but just for me to look at it and make sure it's correct, if I substitute 4 for x, I get 4 times 4 is 16, 16 minus 3 is 13, negative 5 times 13 is negative 65, negative 65 minus 6 is negative 71. That's what your check should look like, right? Step by step, pretty much like I dictated. So there's your homework, guys. In case you didn't see that important word there, yes, we are going to solve and check. Yes, the check for number 4 is going to be a little bit lengthy. That's okay, all right? I would feel terrible assigning you 10 questions and saying solve and check. I don't feel terrible assigning 4, okay? So you're going to solve and check, meaning when you check, you're going to rewrite the original, you're going to substitute, you're going to evaluate. Something I should have mentioned before. Why do we have to always rewrite the original? Well, if you distribute wrong but do everything else right and you check that equation that was distributed wrong, it's going to check. So what I always say is a bad solution checks a bad equation, but it will never check the original equation. So you have to be very careful with that. That's why we always go back and check the original. As always, guys, questions or concerns, you send me a message through under your assignment in Google Classroom. You can shoot me an email, and we will talk about it either at 2 o'clock, or we can talk about it through email, or we can talk about it tomorrow.